All right. So, good morning, good afternoon, good evening, because we can see that the UNI alumni from abroad are all joining this important event, which is very positive because we want to spread a good message of Digital F Africa across the world. So today, our Vice Chancellor, Professor Elvis Asared-Badiako, who was supposed to give the opening remarks, is held up by other emergencies. So I am Amos Kabo-bah, the Dean for International Relations Office, and I'm happy to give some brief remarks about this event. Um, Now, this is an event, the University of Energy and Natural Resources already have a MOU with Digital F Africa to see how best we can be able to build the various data queues to support some of our areas such as mining, crop yield prediction, coastal monitoring. In fact, all the possible sustainable area goals. In fact, the Digital F is able to provide something in that regard. Aside that, our university is also interested to take up developing a program in space science. It's also one of the things that we are looking up to. And the School of Engineering is trying to work on that. And the university too was also selected to be part of the development of the National Space Law, which just happened last week. So there's quite a lot of things the University of Energy is doing and is happy to be part of the Digital Africa program training section, which is happening live today. What we are doing is that this training section will be recorded and will be available via YouTube and all the UNED channels and also the Digital F Africa channels. So it is a section, it's an interactive one. So do feel free to use the chat, to use, at least I know Dr. Ken is going to further provide some more details on that. So that is on the brief remarks on behalf of the university and the management. But I also stand as the co-chair for the program board of GEO, Group on Earth Observations, to say that GEO is very proud of the Digital Earth Africa Probe initiative, which has now become what we call an enabling mechanism, which is rather a bigger word for them. It's a bigger task for them. So, and I happen to have been working with Ken for quite some time, some years now. So I'm not going to introduce my in-law Ken. So I will allow you to introduce yourself and to take the section through. And yes, I'm also happy to say that one of our PhD students, Mr. Eric, he is more like let's call it supporting the Digital Air program in terms of in case any student or staff has some technical issues, please connect with Mr. Eric. He's always sitting here at the Alcis building in room 319. So anytime you have issues, please feel free to contact the office. On that note, I welcome everyone to this exciting morning and session that we are going to have with Dr. Kenneth Bumai from the Digital F Africa program. So, Ken, the time is now yours.
Thank you so much.
You be the moderator and the trainer.
Thank you so much.
Okay.
Yes.
Because of other meetings, you may not be seeing me in, but please take control.
I'll be
And
also
do
the
it the way
headmaster.
you always do. Yes, exactly. Okay, thank you so much. Have a good time with them. Okay, bye-bye.
Thank you so much, Professor Amos, and it's a pleasure to meet the team. And also, it's good to be assisted by Eric, who's one of the co-hosts also in this particular meeting. Thank you so much, Eric, and other participants. So today's session is to give you an introduction to the Digital Africa platform, to see how we can use it for our projects and also our learning, and also how to manage our greater natural resources in Ghana. Being co-hosted by Professor Amos. It's a pleasure to also introduce you to the Digital South Africa platform, which was set up 5 years ago. And the opportunity here was to support different countries in addressing their natural resource management. We are looking at the various sectors and how we can be better prepared to monitor them. So we are working with partners across the continent. In Ghana, we were working closely with the Ghana Statistical Service, then NADMO, then of course University of Energy and Natural Resources, whom we had an MOU earlier in some years on the program. And also we work with other partners across West Africa, East Africa, South Africa, and North Africa as well. The program platform Digital Africa borrows the technology of Digital Earth Australia, where they have already successfully developed their own Open Data Cube a few years ago. This was in the years of 2018. And having this technology, our platform is hosted by Amazon Web Services, whom also have an office in South Africa. So we are working with different partners across the continent and looking at the introduction by Professor Amos. He mentioned about the group of Earth observation, where we are very key partner as well. With the partners in the continent, Africa, we've been able to develop continental services, just showing you some of them on this side. And I'll be able to show you just an example of how they have been developed. So the program Digital South Africa is providing the various satellite data from the free satellites. In the US, we have the US Geological Service, where we have the Landsat 5, 7, 8, and 9. In the Europe, we have European Space Agency, we have Sentinel-1 and 2, and later we'll add 3 and 5 respectively. And the key preposition for Digital South Africa is that we provide it in analysis ready format. It means that now, the longer the days, you don't have to go downloading on a website like that one you use and then going to process with another software. What we provide is always in analysis ready format which has been agreed by the Committee of Earth Observation Satellites, which is very key. Then now you just move from the data to actually getting now information on key sectors of our economy. Just looking at how we can address our coastlines, monitor crops, monitor the changes in vegetation, as well as changes in water, etc., etc. So we are really providing the data to provide the actual insights and powered by Open Data Cube technology, and all our data is stored by the Amazon Web Services. So longer the days, you don't have to focus on huge servers. You can always just come the platform, get the information you need, and we are looking at the various policies, countries, looking at the Sustainable Development Goals, which unites all of us, looking also our repository on GitHub, where you can always come and start and do some innovation. We're empowering various countries in the greater natural resource management, and we're looking at providing the key required information for improving the decision making from water observation from space. We also have cloud-free mosaics called GeoMat. We're able to monitor our coastlines using this particular service, coastline monitoring. We have the cropland extent, which gives us insights on the crops, and also we have water bodies, giving us insights on the water bodies. Then we have fractional cover. On the water observation from space, this one was the first continental service by Digital South Africa in the year 2020. We had some validation as well, and what we were presenting was helping countries get the aspect of 30 or 35 years of getting information about the water availability. We could look at Lake Volta and see how it has changed over time. Also looking at other small water bodies, we can see the trends over time, very key for countries in addressing the water scarcity. On the food security, there was a crop mask tool, which was piloted in the year 2020 and was validated by the different countries. Even in Ghana, we're working closely with NADMO just to present some of the use cases. And it has been very useful to give that separation of green areas to actually crop areas, and looking at how we can actually do some more innovation. Looking now at the coastline monitoring tool, it was developed in the year 2023, and initially this is also borrowed from Digital Earth Australia. And now in the context of Africa, we are working with partners in terms of validation. Key preposition for this service, even showing from the year 2000 to 2024, gives you an idea of hotspots, rates of change, and I'll be able to show you some demos on how we can actually use it to address the greater coastal management. Looking at water body service, was a service which came after, and it shows you the level of water in individual water bodies. Very key to highlight areas which have changed over time, the drought and flooding. So South Africa as a value, we are really helping countries in looking at the climate resilience. We have different notebooks, algorithms, which help us to do quite assessments of what has happened. And we are collaborating with partners across the continent so that we have that participatory engagement and also strengthening local innovations, such as today, the engagements with the University of Energy and Natural Resources and partners. One of the use cases we had in Ghana, working closely with the Ghana Statistical Service and EPA, we were looking at the issue of mining, and we were supporting the use case of Aprama Forest. And with this one, we were able to show some changes, which were very interesting, especially now that we have that particular river going through, and we were able to show some changes. Working closely with a colleague at Ghana Forest Commission, Benjamin, who finished his PhD in Australia, he was able to use the platform to look at crop productivity over time. And in this particular case, he was looking at the aspect of mangoes. He was just using the vegetation indices and trying to understand the phenology over time, the planting season, the raining season, etc., etc. And this was quite an impactful publication as part of his work. Working closely with our own innovator at Big Data Ghana, they had this platform. The guy is called Henry Bafo. He developed a platform which uses Earth observation to show air productivity to farmers. And earlier in the years of 2021, 2022, he was connecting to some of our data services, the analysis ready data, and he was trying to create some pilot areas where he could use this for innovation and inform farmers. Closer home to diversity and inclusion, Digital Africa has been working closely with the youth mappers and also Africa Women in GIS. And we had also a challenge with a technical challenge with the youth mappers where we had winners from different countries and just recognizing some of them. And also the Africa Women in GIS who are really empowering that gap to connect more people in this sector. Access to our platform is fairly very easy and it's free. We have the Digital South Africa map and also we have the sandbox, and also you're able to access the platform through your other GIS software. Possibly you have a QGIS or Esri software you can connect. Then we have access to a learning platform, which is online and free. And hopefully at the end of this session, I'll be able to convince you to enroll in some of the courses. We have a great collaboration and partnership with Esri through the Africa Job Portal. Our data sets are stored in this particular platform, and also providing for that connection with the greater use of Esri, who are the largest industry in this market, and connecting the various tools and platforms. Then also our platform, we can be able to connect to other web services, which is very key to unlocking the potential of Earth observations to support all the sectors and leaving no one behind. Access to the platform through the Digital Africa map is very good because you can even access it on your mobile or your tablet. And the best part with this information is that you can be able to access it from anywhere. And I'll be able to provide you with a short demo on the Digital Africa website. You'll be able to see the platform, the other ones that I've mentioned just now, and also the other continental services that I was able to list, namely, and also access to our analysis ready data. This is very nice that once you're able to familiarize yourself with this information, you can be able to do quite some information. On this particular one, you're able to zoom to our country, Ghana, looking at our resources, looking at our big cities, and even looking at Cape Coast, where I was able to showcase to some youth mapper students how they could track the changes and well as the growth of our city, and also looking at the various districts and zones. So you're able to access to our continental services. We have the data on the coastlines, just looking at our coast of Ghana, how it has changed over time, and even how it's giving us some insights just around Cape Coast, saying the areas which have gained, retreated, You can see the change in the coastlines, different years up to 2024, even looking at some of the vessels and capturing the distances. You can see some of the coastlines could have changed over 100 meters. This is over the 20 years from 2000 to 2024. That's quite a long time. And also with the data sets, you can also add other data sets. We have the data on the surface water, the water observation from space, giving you over 35 years of data at 30 meters, and very useful because it can give us a hint of how our water bodies have changed, or even some of the lagoons. This was just one lagoon around Cape Coast. You could also move around the country and see what is happening. So this one was a case of Volta. You can see from space, and also closely we could look at small individual water bodies around Kumasi. This is Lake Busumtui, and here we could see the trend over many years, how the situation is, and which has been fairly stable. And also we could add other data sets like this water bodies data, which now will show us more information about that particular water body in a small graph. So when you click on it, you'll see the trends from the 80s, the 90s, and times when you experience some changes in the water levels. And this is very key for any water body in Africa. I can imagine some of your projects could be anywhere in West Africa or beyond, just within our continent. So that at least we can say we have a platform in Africa that we could use. We could also do collaborative research from now or even moving forward. So the data on cropland is very useful because it gives us an idea that we can differentiate from the forest to actually probability of cropping areas so that it can unlock our learning. So what we see from space, you could see some vegetation, but getting clearly that, working closely with NADMO, we're looking at cropping around the Upper West region, even looking at southern, southern Savannah and Sudan Savannah. So looking areas around Upper West, we could see areas of probability of cropping, which are higher in the color of yellow. And here, even looking from a water body, we could see possibly people are getting some water from the water body, and looking at the dynamics of the cropping around the region. We could also add some information on water so that we can understand the cropping. So looking also at the crops grown, especially in our northern country of Ghana, looking at the crops, millet, sorghum, and sometimes occasionally maize. This could be very useful. So from this water body, I could see it's a seasonal water body. Sometimes it's green, and so it gives you an idea that it's good to understand the context of the regions. So this area quite around West was an area actually I was trying to look for, which I'll show you in shortly. Sisala was shared by someone from the Ministry of Food and Agriculture, MOFA. So also just going back to the previous example, looking at the changes in our cities, we could load the cloud-free mosaics. So here I have GeoMAD, which is a cloud-free mosaic of Sentinel-2, which is from the year 2017 to 2024, which would be very nice to give you an idea of how the area has changed over time, looking at areas gained, and etc., etc. So it's an average of all pixels in 1 year. So it's very good also when we update our land cover maps, and also we can change the bands on the fly from false color composite. Imagine in your own these remote sensing and GIS courses, you might struggle with bands and another software, but this one you can just do on the fly, even without downloading, to give you a visual perspective of the region. We can also look at the change in vegetation over time, which is very key, because we can unlock and see some years were drier, or even this lagoon was had dried previously and now it's okay. So giving you that dynamics is very nice to really understand what is really happening over time. So we could also move to other regions, even in the previous example, and you can see even the whole country, you can be able to see the change in vegetation, even around the Lake Volta and some of the regions. So this is just a very good platform. You can change between the bands. You can look at the the water index from space based on those years I was about to show you, even looking at the change in the Volta, and even going closer to the example of Lake Bosumchui. We could see the change over time, fairly stable over time, because looking at other lakes in Africa, you could see some which are already dried over time. Even the Wager Reservoir in Ghana, we could be able to see change in time over time, and also changing the various indices over time. So this is quite a nice platform for us to be engaged, to be able to use it for some of our projects, or even some of the just getting some knowledge and insights about our country and how other programs are running, or how other districts are, or what is happening. People are cropping, or the change in vegetation. Even there was a colleague who was trying to look at some changes in some mountains, which was very interesting around Accra. So with Earth observation, you have a lot of potential, doing some research. This is just an example of Wager Reservoir looking at the water quality using the Sentinel-2 index. And also you can share the link with someone, and even you can also create a story map. This is quite a very nice platform for us to be empowered. And you can even change the settings of the map, putting in a 3D based on how strong our internet is. You can be able to see quite some possibilities there, putting in some element of 3D. So it's quite a nice platform for us to be enabled. Cape Coast, just looking at the base maps and how much can even do 3D. It's amazing what you can do with the platform, and how we are really empowered with this session today and other sessions to come, so that we can be more empowered to see how we can use this for platforms, research, even internship, or even possible engagement with different governments, ministries. Many of the days you go to an institution and they ask you for prior knowledge, but once you tell them you know other platforms is good. So the Sandbox is a Jupyter Notebook platform. Here it is steps on how you can actually register and get to start using the platform. And here we are working on different sectors, from agriculture, water, urban, land, coastal management, and we have different notebooks for different applications. And this is just an overview of the platform, that once you're there in the platform, you can be able to do quite some work. And you can look at different areas: land cover, machine learning, from agriculture, food security, meteorology, and so on and so on, even using Sentinel-2 data and other imagery. You can be able to access all these over time. So really many notebooks over many numbers, and these are just the many possibilities. And also looking at the SDG reporting, the program has tried to put the relevant data sets to be required for addressing the particular indicators like agriculture, food security, water extent, and also move into other applications like urbanization, looking at the changes of our cities, the change over time, looking at agriculture, climate action, life below sea, and of course, life on land, very key in terms of land regulation, the land cover, and all those particular indices. So all these are the many possibilities. Yours is just to see where to start from. In terms of agriculture and food security, I'll be able to show you just one or two examples on crop health, and also looking at generating country level monthly vegetation indices. So this is an example of a region, an area called Sisala, which was shared by someone from Ministry of Food. And they were interested to know how we could be able to get individual parcels, yourself digitizing and getting the vegetation index from the Sentinel-2. And this is how this example works in your sandbox. In the real world, there's a notebook called Crop Health. And that particular Crop Health notebook will be able to give you step-by-step guidance where we start with an area of interest where we know, like the one you have just shared, the extents, latitude and longitude. And this was an example of Sisala East. And with the coordinates, you can change between 2 years, and you have this particular dialogue once you run the notebook, and you're able to digitize specific plots of land. Possibly there was a different crop which was grown. And also it's good in the background to know our rainy season around sometimes August, sometimes it delays, and how it will affect our cropping. And just looking at this from different years, you can see different crops being shown. And this can be very useful, especially when we are generating we have different past crops and how they're performing over here, and just giving an indication of whether we are harvesting or some areas we've done some changing of crops, etc., etc. So each plot will have a different plot vegetation index to be able to guide us. So this one, we can also change the dates, for example, to year 2023, and you save it and start and run all the cells. And it will give you this particular dialog box where now you'll be able to get more insights. So changing years can be nice because it can give you an idea of possibly which crops were grown in this particular time, moving from one year to another, and also loading the central data sets at least 50% cloud-free. We're able to get the same dialog box and just digitizing any parcel that you know of or you can see visually. So this one is nice. You can even monitor agriculture just at your fingertips in Sunyani or where you are. You can monitor some cropping, see if they added fertilizer, how the yield were, and how things were performing. So it's quite a useful resource for us to be engaged, to understand the greater crop productivity from space. Then we have the user guide, which is step by step, looking at the different notebooks like this crop health. You can see the dialogue, also some materials that you can link to your research, and also documentation, what has been implemented. So all these are quite useful steps for us to get the knowledge. And also we had the request of getting a forecast of vegetation. So forecasting possibly the next 2 months, how the vegetation will be. So using the same area example, we could actually see the trends and note into what I mentioned in the earlier on, that some areas could have received rainfall and the vegetation would have been greater, etc., etc. Also, we have vegetation phenology, which is very key because it helps us understand the phenology of the area. And based on this particular methodology, we'll be able to see the start of a season and also cognizant of our rainy season and possibly when the harvest will be done. And you can compare for different dates. And also, we can also compare with the radar data, which is a Sentinel-1, where they have different backscatter values. They're normally normalized so that we now get the radar vegetation index and it's not affected by cloud cover. So for most of the Sentinel-1 imagery, we only have 2 in a month, but with the Sentinel-1, at least every 5 days, there's an image. That is the value proposition of the same. Also looking at the same area, we can look at vegetation animation, and this one linking it to rainfall data. We can be able to see how the trends have been over time. This was the same example, the same area where we could see potential rainfall received and area times when we had anomalies. Looking at burnt area mapping has been of interest also for Ghana. And this particular example, we are showing a location in West Mapusi Municipal, and we had a recording of a forest fire. So this particular methodology will be able to show you the area just before the fire and after the incident. Of course, after the fire, there will be a land degradation. We have applications in water resources. Here, just showing you an example of water extent monitoring, because of course, as the time goes, it's good to give you an opportunity to just have an example of what is available. Then from that, the next session will look at possible practical examples where everyone will be able to share what they would like to do. So the case of Bosum Twi, we can look at over 30 or 35 years and see the trends over time. The same example, we're able to get extent using Sentinel-2 and showing you some dates even from 2017. We can see potential times when it has received quite some rainfall, mostly in the month of September, because the rains would have been in August. And also just showing you the example. The notebook is located in the real world example, and yours is just to change the extent of that particular notebook, and that sharing the coordinates of Lake Bosum Twi. And with that, we're able to load the Sentinel-2 data. Everything is done for you in the background, and yours is to get and process and get the results, the ones you just seen. And this one you can take a screenshot or save the image in your disk. Of course, you can also add it in your report. And also you can get an animation of what has happened and what has been captured from the satellite. But now this is just information on the water extent. And also we can also go further and get a graph of how the situation has been, the times when it was low levels in a particular lake, and finally come up with a map showing you just the trend over time. And you can see it's fairly stable. And only in the southwest is where you would have some challenges, some areas being water and not water. We can also look at the same example in the digital Africa map in the water bodies. You can see it confirms some parts of the trend, and this is how complementarily these two services are to each other. So as we also continue, this is an example of another notebook called long-term animations. It helps us to get the same water body like Bosum Twi, and you can see the trends over time. It's very key to inform you about the times it had low levels of water and the times it also gained. And of course, with this, you can confirm with ground information. There's also a notebook on wetland insight tool, and this one we just demonstrated for Wager Reserve in Accra. You could see the trends over time, even the size of the body, which you're able to digitize. Moving to just an example within our brothers in Nigeria, we're working with our partner Afrigist, and we're able to showcase an area which was prone to flooding. And we could also use this example to anywhere in Ghana, where we've reported incidents of flooding and get some key information on what has happened. Moving to just our collaboration with our partners, International Water Management Institute, we have greater collaboration in their project, Digital Water Secure Africa, working in 5 countries, including Ghana. And we've co-developed some learning modules together with IMI on how we could access IMI products in Digital Africa. And we'll continue to engage with them in greater applications such as evapotranspiration, rainfall data, etc., etc. Our partnership with Esri is quite strong, and also just for showcasing some of our applications on flood monitoring. They were able to share in our Digital Africa live sessions, and we continue to add more thematic areas and applications. In terms of urban, I'll be able to showcase you the change in urbanization, like in Kumasi. And in this one, we have a notebook which uses the Sentinel-2 cloud-free mosaics, and it is able to give you between 2 dates how much has changed. And even looking at Greater Kumasi, you can see our regions in the suburb, which have really grown over time. We could also showcase this particular example for us to get just an understanding. So these are the various notebooks as shown. And we could just go to the urban change example. and this one adding the coordinates of Kumasi, we're able to have greater visualization of the same. And from this, we could change between different years and even the size, and even get visually what is happening over time. And visually, you can see there has been some change. Then using this urban growth index called Indici, we're able to see and get some highlights of the urban areas. And also we're able to capture and see the change in the urban area vis-a-vis the cloud-free mosaics, and we can be able to document how much change based on the change in the pixels. City has been really growing over time, and also just remembering the launch of the international airport. So the country is on a good projection path of empowering Ghana. So our cities are growing. We could check step by step many applications in urban growth, if that is your area. Looking at the world settlement footprint, data sets from the European Space Agency and German Aerospace Agency, they have developed the world settlement footprint data, which is very useful because the first example I had was that we can see the change over time, and this one was based on Sentinel data. Looking at the footprint 2015, 2019, we can see how the city of Kumasi has grown over time. And also with that one, we can add in the world settlement footprint data, which now uses Landsat data going back to 1985 to 2015, and you can just visually see how the city has really grown, the 80s, in the 90s, and where we are in the millennium and 2020 especially. So this platform is very nice. Even we had good collaboration to look at urban green space. This is one of our projects done by Sahel and West Africa Club, and they've been looking at a data set called Africa Polis, which shows the growth of cities across the continent. And in this particular case, they're able to reference to other global data sets like European Space Agency World Land Cover data. And then from that, we can see the growth of green spaces over time. Looking at the area of coastal marine, just showing you applications in coastal erosion. This was an example of a village called Foven in Ghana, just around Big Ada. And then I also remember there was another one around Cat Lagoon. And this was an area around dense wetlands where we were checking for the change in the coastline over time. And from that, we could actually see really quite some changes over time. You can even extract the coastline, and just this particular example, you could just see visually how the coastline has changed, even the distance, and you can actually extract this information to guide you for how far the coastline has changed over time. From that example, you also have looking at the South Africa Coastline Dashboard, which gives you an idea of how the coastline has gained or retreated over time, and you can always click on different countries. We had this very nice example on the floating marine debris using a data set from NASA, and who were able to check on the floating debris situation around the area just around Accra. It's a very good data set, especially as we clean our cities. Then cross-cutting applications, I was just trying to show you the aspect of land cover change. And this most specifically on land degradation, which is really affecting our country. Just looking at our land use land cover change over the last, in the years of 2014, 2019, we could see how the trends have been, especially in the northwest, quite a lot of change in vegetation over time. So we can also have a field on how we can use the sandbox, and we had this particular example in getting the land use land cover data for Ghana, for example. And this was just some of the research we'll be trying to do with our partner, Observations Sahel in Tunisia, where they're looking at land degradation for different countries in Africa, even showing you hotspot areas, etc., etc. So this is a very good application, looking at country level land use, land cover change, even looking at change in vegetation over time, and doing even a cross validation. We can be able to see how our countries are changing over time, and also areas which have been a hotspot, the ones I've shown you in the image, and looking at the interaction of the different land use, land cover changes, and seeing the trends of where there's been positive change or where there's need for intervention for different projects or programs by the government. Then also showing you the courses we have, including land degradation course and other courses that will be useful for us as we continue using the platform, and ways how you can connect with us respectively. So also our example on surface mining, I was talking about the Aparama use case has been of interest, and this one is using cloud-free mosaic Sentinel-1 and also Sentinel-1. So we're able to check and give the change in vegetation over time, and also changing different dates. You can get the scenario. So this is how this particular notebook is located in the use case folder under surface mining. And this one you're able to get our area. So we had a shapefile for our Parama forest, and with this one now, we're able to load it. And this is in the background, the notebook, the details, shapefile, etc., even information on the Sentinel-1 and Sentinel-2 used, so that you can get a good extraction of the areas which have been affected by vegetation. This is a very good platform, as you can see, just seeing the changes over time, how the notebook can be very useful, and how the results are useful for different countries as we look. This is Aparama data for data, and the results will be able to show you there. And this platform, you can see overlaying the Aparama forest on the base map. So you could have this example also for another area, because I remember that time I had 4 or 5 areas I was looking at, and this Aparama forest was a very good use case, just showing you around the areas, different dates, and looking at the annual change in vegetation, and also looking at possible mining areas as captured, and also noting that most of activities were around the river because of processing and transportation of the minerals, and also looking at annual change of vegetation over time, and also giving some insights that can help guide how the situation has been. And it's very useful because then the other teams, they mentioned that they were using some drone information to get some of the information on some of the areas, and also to validate the various programs the government has put in place in regulation of mining, and making sure that at least the community is empowered. So you can also change the different dates and run it through, then see the situation in the year 2022 from that year of 2020, and it really gives us very good results towards that particular point, which was this one. So it's a very useful resource. This is the data for 2022, and very informative to just give us the trend over time, and also giving you other connections. We've been working closely with a group of Earth observation as mentioned by Professor Amos, and we've been covering different topics. And also our learning platform is free and self-paced. All the courses will be able to be introduced, just taking you through to be able to see how to access the training platform, and also looking at where to start. And from there, you can be able to see how the courses have been improved over time. And we aim to add more courses to support different learning programs, even the new Bachelor of Science program in Space Law, which will be very key to use some of these resources. So this is an example of a course in agriculture and food security, looking at the different steps and different topics covered step by step. Then from this, you're able to get free certificates of participation or completion, which will be very useful for your resume as well, and also for for your understanding of the platform and also looking at your progress. You can view your certificate, and you can even share with us, showing how you really impacted by the program at South Africa. So the program is here for everyone, leaving no one behind, recognizing everyone in the university, working closely with our partners, and making sure that we empower everybody to empower our countries. So we also have a user guide, also which is self-paced, giving you information about all the topics and most of the questions. I can see where they're coming from. And in this particular user guide, you'll be able to see specific topics like even connecting to other GIS programs, web GIS, even direct access, and so on and so on. So I know it will take some time as well, but the message is that the platform is free. It's here to enable us to impact our learning, even during the times we get some free time. We're able to come to the platform and get more information, even looking at Africa Job Portal. You can be able to connect and see the Digital Africa resources in that platform, where we are really empowered by our partner Esri to make sure we connect with everybody. Even we have tutorials that we're developing with them, which are step by step. And this one will really empower us to make sure we connect with everybody. So it's quite information is here. It's impactful. It's very useful. Even looking at the data catalog that we have, as well as the imageries that we add, and even the live sessions that we have every week, Wednesdays. So they're quite useful information, as you've seen. And also we have the Digital Africa live sessions in English and French. The session for this week on Wednesday will be in French tomorrow, and thereafter the other one will be in English. I'll be able to share all the details. Digital Africa acknowledges the partners, Helmsley Trust and Australian government, and other partners, including University of Energy and Natural Resources in Ghana, as we grow to enable Africa, the Africa we want. And I'm very grateful for the session that we've had today with everybody as connected by a professor. And I believe we'll be having some time to interact with one of you in the question and answer session. Thank you so much.